In this video, we will be looking at how to find the equation of a parabola when we're given either the graph itself or from a description. From a graph, we can find our factored or our vertex form directly by identifying a few key properties. So your first step is to identify either the vertex or the zeros, and that will give us either the h and k in vertex form or the two brackets in factored form. But then we also need our a value, so to figure out our a value, we can visually look for the step pattern. Now there's also a algebraic way to find the a value, and we'll look at that in other questions. So for this first parabola, I can see that the vertex is at 1, 4 if I want to find vertex form. If I want the zeros to do factored form, those are at -1, 0 and 3, 0. So I can get vertex and factored form here. Now let's just look at our step pattern to figure out our a value. So I'm going to go from the vertex, and when I move to the right one, I go down 1. So that would be -1. Then to the right one, down 3. To the right one, down 5. So my step pattern here is -1, -3, -5, which just means that our original 135 has been multiplied by -1. So our a value is -1. Now, if we want our vertex form, we will start with the a value, which we can write as negative or -1. The choice is yours. And then because our vertex is 1, 4, inside my bracket, I will write x minus 1 squared because I'm moving to the right one, and then plus 4 on the outside. So that's one way. If I want my factored form, I will again write that negative or -1 in front of my brackets, and then I'll set up my two brackets. For the 0 that's at -1, I'm going to write x plus 1, and for the one at +3, I'll write x minus 3. And now I have my two equations. If I, however, wanted the standard form, I can just take either one of these and expand and simplify. Let's try the next one. So I want you here to identify the vertex, the zeros, and try to see what your a value is by identifying the step pattern, and then try to set up your two equations the way I did in the previous example. Then come back to the video and we'll take it up. All right, so the vertex is 3, -2. Your zeros are at 2 and 4. But now the step pattern to get our a value. From the vertex, I'm going to move to the right one, and I'm moving up 2. Then to the right one, and now I'm moving up 6. And then I can't see the rest of it. So the step pattern I have is 2, 6. So originally it should have been 1 and 3, but it clearly looks like our step pattern has been doubled to get 2 and 6. You can also find your a value just by looking at that initial step, because the original step pattern starts with 1. So whatever a is, when you multiply it by 1, it will give you the a value. So a in this case is 2. So for your two equations, hopefully you had y equals 2, x minus 3 squared minus 2 for your vertex form. And for your factored form, 2x minus 2 and x minus 4. And again, we can expand and simplify this to get our standard form if we wanted to. Now, let's move on to a description. Now, from a description, you won't be able to find your step pattern visually. So we're going to have to solve for it algebraically. And this algebraic method you can actually use for the graphing examples we did above. All right, so from a description, the first thing you're going to want to do is either put the zeros into factored form, or maybe you're given the vertex, and if you are, you're going to put that into vertex form. So it's really going to depend on the information that's provided. So after you do that, you're going to be given one more point, which represents an x and a y. So you're going to sub that in for x and y in your equation to isolate for a. So this is kind of familiar to when you're doing y equals mx plus b for a linear example and you're trying to solve for b. But here we're solving for our a value. So let's try our first example. The vertex is 4, -2, and the parabola passes through the point 7, 1. So we start with our vertex. I don't know my a just yet, so I'm just going to write x minus 4 squared minus 2. So I put my vertex in for that h and k value. Now, the point that we're given, 7 is x and 1 is y. So instead of writing y, I'm going to put 1. And then instead of writing x, I'm going to put 7. And now it's just a matter of us cleaning up. Now, this portion here in the bracket that has been squared is attached to a by multiplication, but the -2 is not attached to that unit. So the first thing you want to do is bring that -2 over and it will turn positive. So 1 plus 2. And now inside the bracket, make sure you're doing BEDMAS here. 7 minus 4 is 3. And then that value will have to get squared. Now you can do this all in one step, or you can do it in 2. Now 1 plus 2 is 3, and then 3 squared is 9. You can write this as a times 9, but I prefer writing 9a because that looks a little more familiar. And now I can clearly see that I'm just going to divide both sides by 9, and I'm going to reduce that 3 over 9 to a third. So our a value is 1 over 3. And now we can put it all together. 1 over 3, x minus 4 squared minus 2. So again, we put our vertex into vertex form. We took our point and we subbed it in for x and y. Always move the constant over to the other side while you clean up the bracket, and then divide out that coefficient of a, and you're done. Now, let's try a zeros example. So the zeros are 2 and -10, and our parabola has a y-intercept of 5. So let's start with the zeros. I'm going to write my a, and for my first bracket, the 0 is 2. So I'm going to write x minus 2, remember the opposite sign. And then we have -10, so I'm going to write x plus 10. Now, for a y-intercept, don't just plug in 5 for y. A y-intercept is a coordinate, and the coordinate is 0, 5, because every y-intercept has an x-coordinate of 0. Now I can clearly see y is 5, and in both of the x's, I'm going to put 0 in. And now there's nothing for you to move over to the other side because there's nothing being added or subtracted outside the brackets. So I'm just going to clean up my two brackets. 0 minus 2 is -2, 0 plus 10 is 10, and now all three of these are attached by multiplication, so I'm just going to clean it up. -2 times 10 is -20, and again, I'm just going to write it as -20a instead of a, and then in brackets -20. And then I'm going to divide both sides by that coefficient, and then reduce your fraction. So 5 over -20 is the same thing as -1/4 for our a value. And then again, we can put it all together. So our steps are very similar. It's just the simplification and the isolating for a that is slightly different. In factored form, you're not bringing anything over. You're just cleaning up that multiplication part with the brackets and then dividing up the coefficient. And then that's it. Okay. Let's try a few more examples. So for the next one, we're given the vertex. So we know we're going to start with vertex form. And then we're also given a 0. Don't let this statement about the 0 at -3 fool you into thinking you have to start with factored form. This is just the other coordinate. And a 0 of -3 can be written as -30. So in this example, the vertex is -4, 3. And your coordinate that they're giving you is -30. So why don't you pause the video here and try this example out. Put the vertex into vertex form, sub your point in, and isolate for a, and then come back here to check your work. All right, so hopefully for your vertex form, you put x plus 4 squared plus 3, and then we're putting 0 in for y, -3 in for x. Now this +3 at the outside of the brackets is going to move to the other side, and its sign will change to -3. And if we clean up our brackets, -3 plus 4 is 1. And when you square 1, it's still 1a, which you can just write as a. So your a value should be -3, and then here it is put all together. Let's go to the next one. Both zeros are located at 5, and the parabola passes through the point 2, 3. So I'm just going to start this off for you. If both zeros are located at 5, that doesn't mean you're just going to have one bracket. It means you're going to have two identical brackets. So if the 0 is at 5, I'm going to write x minus 5, and then x minus 5 again, because both of the intercepts are at that point. And now I want you to pause the video, plug the point in, and solve for a. And in this example, I want you to actually take your answer for factored form and then convert it into standard form as well, just for the practice. All right, so you should have plugged 3 in for y, 2 in for x in both brackets. When we clean up our brackets, in both we should have -3. -3 times -3 is +9. I divide out the 9 and I reduce my a value to 1/3. So when I plug it into my factored form, this is my final answer. Y equals 1/3, x minus 5, x minus 5. Now, if they ask for factored form, you'd be done right here. But I did ask you to go a little further and put it into standard form, which means no brackets. So we're doing FOIL here. Now, remember, when you have this type of setup, do the FOIL first. Deal with the brackets and then distribute that coefficient at the very end. So x times x, x squared. X times -5, -5 times x, and negative times -5 to get this. I like to collect my like terms first in the bracket to get -10x, and then distribute that 1/3 in. Now remember that all of these values in the brackets are over 1. So that when you multiply, all of the top numbers are multiplied by the 1 in the fraction, and all of the denominators are multiplied by 3, so that your final answer is 1/3x squared minus 10/3x plus 25/3. And then that would be it for your standard form. And again, your standard form gives you your y-intercept, and here it is, that 25/3. All right, let's go to the next ones. The next ones are a little trickier in that you have to do a little bit of side work to get full information. So here we're told that our zeros are located at 0 and 6, and the parabola has an optimal value of 36. So this should make you think of the vertex, but you don't have full information about the vertex. You know that the optimal value is 36, which is the y-coordinate, but you don't know the x-coordinate. So you have to figure that out. But you are given the zeros, and you know that the vertex is exactly halfway. So I can actually find the x-coordinate of my vertex by averaging the zeros. So I add 0 and 6 and divide by 2 to get 3. So my vertex is 3, 36. And now the choice is yours because you're given the zeros and the vertex. So if you want, you can use factored form or you can use vertex form. The choice is yours here. So I'm just going to use factored form just to show you how to deal with the x-intercept of 0. So if I have my x-intercept as 0, I can write it as x minus 0, and then for the other one, x minus 6. Now, this might seem a little silly because when you subtract 0, you're not doing anything to the number. So if you want, you can just write this as x in the bracket. You don't have to subtract or add anything. But you could also write it the way I previously did. All right, now let's plug our point in. And our point is the vertex. So instead of y, I'm going to put 36. And instead of x, I'm going to write 3. And now we can clean it up. 3 minus 6 is -3. Clean up your multiplication. 3 times -3 is -9. So -9a. And then divide out that -9 so that we get -4 for our a value. And now we can put it all together. And now here I do want to see the simplified form. I just want to see an x. I don't even want to see it in the bracket for that x-intercept of 0. Now, because we have our vertex as well, We can actually write this in vertex form as well, if we really wanted to. And here it is, -4 x minus 3 squared plus 36. And if we wanted standard form, we could expand and simplify. All right, let's go to our last one. One of the zeros is located at 3. The axis of symmetry is 4, and the parabola has a y-intercept of 60. So here, the y-intercept is going to be that key point that we're going to plug in to get a. So that's 0, 60. But now I don't actually have full information about my zeros, and I don't have any full information about my vertex. So what I'm going to do here is draw a little sketch. So my 0 is located at 3. Then that axis of symmetry that cuts it in half is located at 4. And I know that there's symmetry in my parabola. If one of my zeros is 1 unit away from 4, the other one should also be 1 unit away, but on the other side. So if the axis of symmetry is at 4, the other one should be at 5. And now if my zeros are at 3 and 5, it makes perfect sense that when I average them, I get that middle axis of symmetry at 4. So now I have my zeros as 3 and 5. Now I know the zeros, I can put them into factored form, and I have that key point of 0, 60 to plug in to solve for a. So in these last two examples, you have to do a little bit of extra thinking and solving using your knowledge of averaging the zeros to kind of get full information. So I want you to pause the video, put your zeros into factored form, put your y-intercept to get a, and then finalize this question. All right, so when we put our zeros in, we should have x minus 3 and x minus 5, remembering to switch those signs. We put 60 in for y, 0 in for x. Clean up your brackets to get -3 and -5. And when we multiply them, be careful here and make sure you have positive 15 times a. Divide both sides by 15, and you get 4 for your a value. And then you can put it all together. And again, I can get this into standard form by expanding and simplifying. Or if I wanted to get my full vertex, because I know the axis of symmetry is at 4, I can plug that in for x to get the y coordinate of my vertex. So I can do lots of things here. But just to recap quickly, if you're given the zeros, you'll put them into factored form. If you're given the vertex, you'll put it into vertex form, and then you'll be given a second piece of information with a coordinate that you can plug in to solve for a.